Good afternoon, everyone. Welcome to the Day 3 afternoon session of International Conference on Ancient Indian Astronomy and Mathematics, with special reference to Kerala, organized by University Grants Commission, Stride Component 1. This is the session 9, and this session will be handled by Professor Satyanath Kichanaswamy, and there will be a validatory session at 4 p.m. To officially begin this session, I would like to invite Shruti P.A., Stride member, Department of Sanskrit, Sri Krishnapuram V.T. Bhattadripad College, Palakkad, for the welcome speech.
Thank you, Arjun. Good afternoon, everyone. The sessions are becoming interesting as we progress. I hope everyone enjoying it. It gives me an immense pleasure to heartily welcome everyone to this session. Our presenter in this session is Professor Satyanath Kichanaswamy, Professor in Mathematics, Université de Reims, Champagne, France. He is going to present a paper on geometry without figures, mathematics as a poetic discourse in Indian text. A hearty welcome, sir. And I welcome each and everyone. Once again, welcome you all. Welcome. Thank you. Thank you, Arjun.
Thank you, ma'am. For session 9, we have Professor Satyanath Kichanaswamy, University Professor, RAS Mathematics Laboratory, University of RAS, Champagne, Dean. He will be delivering the session on the topic, Geometry Without Figures, Mathematics as Apodictic Discourse in Indian Texts. His doctoral thesis is in quasi-linear elliptical problems from University of Paris. Professor Satyanath Kichanaswamy is a member of many reading committees and editorial boards such as International Journal of Analysis and Applications, Abstract and Applied Analysis, and International Mathematical Forum. His major publications are Nonlinear Wave Equations and Fusion Reduction, Application to Geometry, Cosmology, and Mathematical Physics. He is a member of Asian Society with interest in areas such as differential geometry, relativity, computer vision, history of mathematics, and Indology. With great honor and respect, may I invite Professor Satyanath Kichanaswamy for the session. I welcome you, sir. The session is all yours.
Can I share my screen?
Yes, sir, please.
Let me put it in full screen mode. That would be better. You see. Right. Yeah. I hope everybody can see and hear me correctly.
Yes, sir.
Okay. Okay, so first of all, thank you for the very kind introduction, and let me thank Dr. Parvati for her kind invitation and also all the organizers for their efforts in making this conference possible. I'm very happy to see that there is a move towards the edition and publication and analysis of ancient texts, especially from the South and especially in Malayalam and Sanskrit. Yeah, I think this is something very important, and I think it should be furthered. This talk is actually the topic is actually a reaction to the concept note that Dr. Parvati had sent me that included the project topic for this conference, and that contained the following passage. The significance of oral learning has been grossly ignored in the current education system, meaning Kerala, and the result of this omission has been disastrous. So I hope that maybe it would be interesting here to try to think about what the consequences are of scholarship that is primarily based on non-written representations, And what is the impact of this feature, which is a standard feature of mathematics in India since the Silva Sutra times? What is the impact of this feature on the structure of mathematical discourse? And I want to argue that actually there is an underlying conception of mathematics here, which is that mathematics itself is a discourse, which is something that actually is relevant for other cultures, but I'll focus here on India because it's particularly tied up with other cultural elements I try to explain. So the three questions, well, there are two listed and the third, which is in the background. The first question is, like I said, does the unwritten nature of Indian mathematical texts explain in any way the form of Indian derivations? And the second question is, why were these derivations missed for so long? And of course, the third question that's behind it is, are there Indian derivations? That is, it's not absolutely obvious when you read ancient texts that they do contain Indian derivations. And actually, what we are going to argue is that it's the discursive structure itself that contains the elements of derivations. Therefore, if you read text as lists of rules or as unconnected sentences that simply record facts or beliefs, then you don't see the derivation because you have thrown out the discursive structure. And here I'm going to be primarily interested in connected discourses that provide rigorous derivations. So there are other kinds of derivations that may be heuristic, that may be interesting for other reasons, but I'm only interested in rigorous discourse, what I would call apodictic discourse. Apodictic is a term that comes from Latin that's very common in philosophy that refers to what is really established by reasoning. So it's if you want, it's an apodictic discourse is a discourse that is a proof in itself. I'll define it a little more precisely in a moment, but you may keep that as a simple definition. So we suggest that eschewing writing encourages abstraction, because of course, if you only work with world representations and you don't write anything and you don't really perform things while you're thinking, then you have to internalize everything and you have to think in your head. And when you receive a discourse from your guru or someone else, then this text requires analysis because all information is not immediately apparent. And therefore, it forces you to think. And it turns out that in India, those texts are very often meant to be read at several levels. That if you're only interested in the result, then you just get the result and you don't worry about anything else. If you want to know more, then you start analyzing and you discover that there's a lot more than what appears at first sight. So this analysis is also relevant to other cultures, and the upshot is that there is a way of thinking about mathematics that helps you understand better the relevance of history of Indian mathematics, not only to history in general, but to contemporary research and teaching. I begin with a short list of definitions, and then I'll go through some classical texts about learning and writing in India that illustrates some of the points that I made. And then I show you an example of a derivation indicated through the discursive structure. I'll give you already the short version. There are two rather long papers that develop that. So just want to show you what I mean by apodictic discourse and how you can, get at a derivation, at an original derivation, it turns out, by analyzing a text. And then we'll see, if time permits, why this was missed. And it will show I would like to focus on the central place of Southern sources in the historiography of Indian mathematics, particularly in Malayalam, but not only in Malayalam. And then I make some concluding remarks. So this builds on a number of papers that show that how Brahmagupta obtained his results on the cyclic quadrilateral. And despite what has been said, as many of you know, I suppose, people used to say that Brahmagupta did not specify that these quadrilaterals were cyclic, but actually it did. And he actually not only specified the conditions of his result, but also gave the main tools and the main arguments for the derivation. The same type of approach applies to Tartaglia, who obtained in the 16th century important results on cubic equations that represent a turning point in the history of mathematics. And we have shown that actually he's working on not on geometry. I mean, he said that his results are geometrical, but what he meant was not about making physical cubes and playing with cubes and dissecting cubes. He thought about using what is called the theory of continued proportions, that enables you to deal with powers that are not limited to cubes, that can be represented. You can have fifths, sixths, and in the Italian literature, you have the 21st power. You have all sorts of higher powers. And at that time, they could justify these things on the basis of their interpretation of the theory of proportions. So the message here is that you don't understand. If you try to read Tartaglia on the basis of what Cardano said about him, then you don't understand anything. But if you read him against the backdrop of his master, maybe Pacioli, one of his masters, one of his main sources, he explains who his masters actually were. Then if you read that against his own sources, then everything becomes clear. This also implies that we need to have a rather subtle, nuanced model of transmission. It's not because two people are in contact and people are mathematicians that they know more or less the same thing, that they are going to understand each other. So things can be transmitted partially and not transmitted, misunderstood, reinterpreted, things like that. And in particular, I'm not ruling out, I'm not talking about transmission in this paper, but it is possible, it's not established, but there's nothing that rules it out, that the results on identities with cubes in mathematics in Kerala, in Sanskrit and in Malayalam could have been transmitted. That's a possibility, but first we need to have texts, and we need to understand them correctly. If we don't do that, there's no point thinking about transmission. And that's a very general fact. We don't understand text well enough in order to speculate about transmission. And on the other hand, conversely, if you understand better mathematical text, and if you do that really in depth, then you get new models of transmission that then can be applied to other situations. And then another example is how Baudaina obtained this approximate quadrature of the circle. Another one that I worked out is the proof of the Cauchy-Schwarz inequality, or rather the Cauchy-Bunyakovsky inequality. If you look at Bunyakovsky's paper, there are interesting things that happen. If you look at Schwarz's paper, other things happen. So there are lots of examples that all point in the same direction. It takes work to understand what an author is really telling you. The same things actually can be applied to Indian philosophy. For instance, how the concept of sadasat, which is a technical concept in Sayositanda, arises. So you need to understand what they mean by sat and what is asat, and why do you introduce something which is neither sat nor asat, which is sadasat. Again, the third paper is an analysis of the first 4 lines of the kapu in the Sivanyana border, the Tamil Sivanyana border, which started Kala Nijan Malay. A verse that maybe some of you remember. And the fourth one is about the analysis of the Lingodbhava theme, which implies, as you know, that you must have a notion of something which is infinite, and infinite in both directions. I think the theme is famous enough that I don't need to remind you of what it is. So the definitions, before we run into the main part of the paper. Apodictic discourse is something which is a rigorous, conclusive, and motivated result. A dogmatic discourse, by contrast, is a rigorous, conclusive, but not necessarily motivated or motivated in an artificial way. So it doesn't tell you where the result comes from. A proposition is a statement, could be a theorem or a problem, but in India, it could also be a definition, an indication, or a rule, or something that combines these things in a particular way in order to indicate their logical relations, which is part of the reason the discursive structure is complicated. And then we distinguish derivation, verification, and proof. The derivation is a motivated sequence of arguments from assumptions to conclusion. It's rigorous if the sequence of inferences is complete, but if there are gaps, it's merely heuristic. Well, you can have small gaps, but if the gaps really require new ideas, then it's heuristic or plain wrong. The verification is checking that the result is correct, but that in order to do that, you need to know the result. So it's not going to tell you how you obtain the result, how you guess the result. And the proof is a non-motivated or artificial derivation. Or it could be heuristic or rigorous or plain invalid, as before. And only minor gaps are maybe allowed if you want it to be rigorous. And from the point of view of Indian philosophy, the game is to use only anumana on word representations. You're not supposed to say, well, I see that, and therefore it's true, because it doesn't prove anything. You need to prove that the relation between the word representations are really what you claim they are. Okay, there are a number of classical texts that are probably, some of them are probably familiar to you, especially if you know Malayalam and its history, to show that oral knowledge, that is knowledge required to the ear, is paramount, but it requires analysis. So the first is a very famous passage from Tirkover. I suppose everybody knows that the Tirkover is a remarkable text because it is a text that's really accepted by all schools in India. It's written in such a way that you don't rule out anything. It's written in such a way as to appeal to every possible schools. That's for why it is called in Tamil Podu Mare. That's the Mare that's common to all systems. So the famous verse is Silvakur Selvam Chevi Selvam, Achelvan Silvakur Lelan Tare. Which means the oral resource is the resource by excellence. It takes precedence over all the others. So you see already, so it is telling you that knowledge through the ear is paramount, is very important, but there are others. So there is also visual knowledge, reading, and so forth that can also be useful. It's not ruled out. And then yenenba, yene yejitenba, ivirundum, kanenba, varumu, which means what one calls numbers on the one hand, letters on the other, are called the eyes of living souls. Sorry. So that means that visual knowledge is obviously not to be neglected, because you see now the reference is to the eyes, and numbers or letters, of course, what one calls numbers and letters, it's of course mathematics and literature, and not just numbers by themselves. They are called by scholars, so this is a scholarly knowledge. We're not talking about just the common elementary aspects of it. Then Yepohur yar vai ketpinum, apohur me pohur kanbadu ahil. That is to perceive the real substance in any matter whatsoever, whosoever be the one who utters it, is reason. Reason with the capital R is arrivu, because it's not really knowledge by just knowledge. It's the sixth sense that reasonable people possess. Makel as opposed to marker. So this is a distinction introduced in Tolgapion, which is, of course, the first known grammar of classical tempo. So you see, this means that oral knowledge is not immediately meaningful. It needs to be analyzed by reason as the sixth sense. And this implies replacing sense objects by word representation. You hear something and then it brings an idea. It's not just a sound. And then yen purlevaga cheda choli tan piravai nun porul kanbadu arivu. So to speak so as to convey the substance of one's ideas, yen purlevaga cheda choli tan piravai nun porul to perceive the substance, and that's also to perceive the subtle substance of other people's words, and that is reason. So you see that analysis is needed to construct one's own discourse, but also to understand other people's discourses. So you see that in all this, the notion of oral knowledge is not simply communication by the sound, it's analysis of the words. And if you only have to work with the words, then you need to understand the articulation between the words and reasoning. Now, in philosophy, there are also other aspects that are relevant to our problem, namely the fact that different discourses may be produced for different audiences. In the Chandogya Upanishad, Narada, who comes to Sanat Kumara, tells him, "Teach me, venerable sir," and he gets the answer. "Come to me with what you know," and there is a list of what he knows that's given just after that, which includes Rasi, that's probably mathematics. And then I will teach you what is higher. There's another idea that the master will not correct mistakes if the student is not ripe for improvement. So the classical example is Indra and Virochana who go to Prajapati for knowledge, and they get partial knowledge. And Virochana is very happy, doesn't see any problem. Indra thinks about it and figures out that there's something wrong with it. The teaching has to be incomplete, comes back, and then he gets a second piece of knowledge. And then he lives again, and then he realizes that once again he hasn't understood everything. And then the third time around, then he gets full instruction. The instruction is about the three stages of conscious waking, the Jagrat, and Swapna, and Sushupti, and dreamless sleep. Another example is the well-known Satyakama, who teaches his student fully only after the student has obtained a certain level of knowledge by his own means and has perceived the need for knowledge. And Vedic ritual also, so there's another passage from Chandogya Upanishad, has three correlated dimensions, which are action, language, and silence. Silence is represented by the Brahman. There are several people that have to work together in Vedic ritual. One of them is Brahman, who is supposed to keep silence. Actually, he speaks out only if there is something wrong. And so the text explains that there is a correlation between these three dimensions. So it means that language is not autonomous, but it's correlated with thinking and action. Okay, so in mathematics, this means that figures are not needed if you want to apply this model of thinking, because you make language precise enough so that you don't need them, and that encourages you to perform all reasoning mentally. So it doesn't look like what we usually do nowadays, but obviously people were very good at that, because there are, for instance, challenges when Bhaskaracharya tells someone, well, tell me immediately the smallest number such that, and if it's done immediately, it has to be, this is part of common knowledge of the time that is not going to be made very explicit. In particular, In ancient India, there are no angles or parallels, or in arithmetic, there are no prime numbers. They are not needed at all. And another feature which is important is that quadrilaterals are more important than triangles, which makes perfect sense. But I may not dwell upon that, but there is a coherence to that. But we need to keep that in mind. Now, let me give you an example of I'm keeping track of the time, so please tell me if I'm running too long. Feel free to interrupt. Okay, so we have seen that there is, there are quite a few texts that say that knowledge should primarily be imparted orally, and that this makes for a very precise communication that needs analysis, that needs care on the part of the teacher who produces the discourse, and then on the part of the student who receives the discourse. So language is about discourse, is not just about a string of unrelated rules. Let me show you an example of how that actually works. So in the issue of understanding ancient Indian mathematics, the cyclic quadrilateral has a special place, because these propositions are first found in Brahmagupta's Brahmaspura Sitanda, that they are not found anywhere else in the world. And they are not found later either, that is until the Madhava school, because they were misunderstood later, even in India. And this is the point that Saraswati Amma stressed, one of the stalwarts, of course, of the study of Indian geometry, as everybody here knows, I suppose, that there were several conceptual frameworks in India. In particular, there were some people that only considered cyclic quadrilaterals, which is the tradition that goes back to the Sula Sutra, basically. And then there is another tradition that doesn't seem to use cyclic quadrilaterals at all. We don't really understand why. But at any rate, this implies a failure of essentialism. You can say that there is one Indian mathematical framework. There are several Indian mathematical frameworks. There are a lot of schools, and these schools interact, but they did not fuse into one single school. And then many complicated proofs of Brahmagupta's results were given later, and there is no obvious proof. That means that you see, look at the situation. You have a result in Brahmagupta. It's not found earlier, and people that came later for about 1,000 years said it was false or incomplete. And then when you find proofs, the proofs are very complicated. There's nothing particularly obvious about them. So it means that these results must have been obtained by Brahmagupta or someone close to him, possibly his father or someone like that. And it is a difficult result. Therefore, it's not plausible that he should have omitted the derivation. So he must have indicated it somehow. This is a very special. There are few results. There are a few other results like that in India, but not that many. Let me explain what he's doing. If you look at proposition 21 to 32 in the Brahmaspura Sitanda, you find that there is a clear objective. The objective is to find all the lines, that the lengths of all the lines determined by a trilateral, by adding 1 point on the circumcircle of the trilateral, and then by performing projections, intersection, extensions of known lines in all possible ways. And I'm going to show you the picture in a moment. In order to do that, he introduces a word which is Tri-Quadrilateral. This word is only used by Brahmagupta. You don't find it in any other, in all of Sanskrit literature, you don't find it except when people are quoting Brahmagupta. And we see that it can only mean a triangle completed by 1 point on the circumcircle. And then when I say projection, so forth, I mean computing lambda, or the variance perpendicular, avada or avada for segments, kanda, which are determined by intersection. So, and this is what he actually does. So if you imagine this is a circle, so you have the cyclic quadrilateral. So imagine you have a triangle like that, then you add 1 point. And then you find the diagonals. You extend. So you extend the sides. You raise perpendiculars like that, and you connect all possible points. You create intersections like the intersection of the diagonals, and then you can project these things. So you get all sorts of segments. So this portion, this diagonal, this perpendicular is divided into two portions, so forth. It gives you the way to compute everything. And at proposition 32, that's what it does. So it's flattened because, of course, if the you can have any shape for the quadrilateral, but if it's if it were higher than these points would shoot up and would go out of the picture. The Suchi Chetra, and so this is something that's found. So the tri-quadrilateral is, you say you take a triangle, it's trilateral because there are no concept, and the concept of angle as a magnitude attached to a point is something that doesn't work. So I'm trying to avoid that. It has been pointed out that you don't find the concept of triangle in this sense in any culture that did not receive Hellenistic influence. So the tri-quadrilateral, that you take a trilateral, you take a fourth point, and then you complete it. And then when I mean perpendicular, so you see, for instance, here, the green section, the green line is a perpendicular, dropped on this line, and it cuts off things that are called segments, that is the avada. But if you look at the intersection of two lines, such as the diagonals, then you get four portions determined by so these are the khanda and the avada. These are two different things. And it shows you how to compute everything. So what is the structure of his discourse? So the 21st proposition introduces the area of the tri-quadrilateral, and it gives two expressions, one which is gross and one which is exact. And then he takes first the isosceles trapezium and then the trilateral and computes the heights, diagonals, and segments. Of course, there is no diagonal for the trilateral. The diagonal is the side. And then in 24, he gives a proposition that looks at first sight like saying 3 times the Buddha Kodi Karna Nyaya. But exactly the same thing, except for permutation. But if you look very carefully at the way it is stated, actually, if you apply the result not to one trilateral, but to 3 different trilaterals, then you find that it gives you a theorem, which is that the trilateral of which the diameter is the diameter of a circle is the basis, of the circumcircle is the basis, must be a right triangle, which is something he's going to use here. In 25 gives you a form of a geometric proportion, what he calls anupata, and that gives you the portions of diagonal for the isosceles trapezium. So you see, little by little, you're building all the information that we want. diagonals, of course, the two laterals should be swept. And then he gives a formula for the circumradius of the isosceles trapezium, and then for the quadrilateral with perpendicular diagonals. This corresponds to two different expressions and two different proofs. And if you think very carefully about what it means, you find that these are two very beautiful results. And it's for the second one that you use 1224. And then in the 27th proposition, he gives the circumradius for the trilateral and the tri-quadrilateral. That's the second time and only time in the entire Sanskrit corpus that this is used, except in quotations, like I said. And at this point, you have all the means to prove the formula for the area. The idea being that you express that the quadrilateral is decomposed into two triangles, of course, by a diagonal. And these triangles have the same circumradius and the same circumcenter. And if you write these two things, then it falls. In 28, it gives you the two diagonals of the general tri-quadrilateral. And this is here that you need to use an observation derived from the gross formula, that the gross formula cannot be correct because it doesn't involve the side lengths in a symmetric way. So this is somewhat long. I'm not going to it's really very beautiful because Brahmagupta's proof differs from all the other proofs that have been given. There have been quite a few. Observe that it doesn't talk about the third diagonal because he's not performing a shift of the sides. He's simply saying that the formula should involve the sides in a symmetric fashion. It's an algebraic symmetry, if you want, rather than geometric symmetry, to use a modern word. And then in the 29th proposition, he says that the segments, so he gives you the segments and perpendiculars in the general situation. And then there is a result called Brahmagupta's theorem. If I have time, I'll show you what it is, but it's fairly known. On the portions of diagonals in the quadrilateral with perpendicular diagonals, it's called Brahmagupta's theorem because it's a theorem that when it was found in Brahmagupta's world in the 19th century, it turned out that there was quite a bit of, quite a body of knowledge on triangles and stuff. But this theorem was completely unknown in the 19th century, which means that it is not possible to derive all the results of ancient mathematics simply by deductively churning out the results on the basis of modern mathematics. It's not going to be enough. And the way he expresses, of course, the result is very interesting. I don't have time to explain that. And then in 32, he gives the solution of the problem general situation, because now you have all the means to compute not only the portions for the segments and perpendiculars, but also the portions of the diagonals. That is what you do for this particular case, you can also do for the general case, but the formula is, of course, a lot more complicated. So you see, he has a definite, I mean, if you look at it as a connected discourse, and it goes on, there are other things about how to generate quadrilaterals in numbers, but this is not germane to this particular problem. So you see that he has a very clear goal. He introduces it, and he sets the stage for everything, gives you all the tools one by one. And if you read it very, very carefully, then you see that he has given you everything. He has given you all the means to understand what he wants you to find out. But if you assume that while he's redundant, he's just copying stuff from other treatises, and he doesn't understand what he's talking about, then of course you won't see anything. Okay. Am I doing time wise? Okay. So maybe let me just show you how you know that that Brahmagupta indicated that these quadrilaterals were cyclic. Here's 1221. I'm taking Colebrook's translation basically, but I'm simply not replacing tri-quadrilateral by triangle and quadrilateral. So this figure is supposed to have 4 sides, and it's supposed to have an area, so it's supposed to be something that's a closed figure. And then here you are talking about the exterior circle, the corner split, that's Colebrook's translation. It's a corner split return with the circle that touches the corners, which, well, that is the circumcircle. There's no issue about that. The real issue is to whether tri-quadrilateral is also possibly a triangle. Now, that's not possible. If you do that, then he's telling twice the same information, that it is redundant. And you know that, especially in Sanskrit literature, you don't want to have anything redundant. Anything that can be inferred has to be suppressed. And so let's try to understand this triad thing. So you have a tri-quadrilateral. It's a figure that has 4 sides. It's inscribed in a circle. And then in order to compute its circumradius, you need to know a perpendicular. And this perpendicular is the perpendicular not of the tri-quadrilateral, but of a triangle within it. So if you look at what this means, so you have a closed figure, but it is determined by the height of a triangle. So it has to be not just a quadrilateral, it has to contain a triangle which is distinguished. So you have a distinguished triangle within a quadrilateral, and that is a tri-quadrilateral. So that means that the tri-quadrilateral can only be obtained by completing a triangle by adding a 4th point on its circumcircle, which is the picture that I showed you before. Then the 4th point could be obtained by symmetry with respect to 2 diameters, and these are the 2 cases that are described in 1226. The case where you swap things horizontally, so to speak, gives you the isosceles trapezium. So everything is clear. I mean, there is no discussion that he made his point clear, but you need to read him very, very, very carefully. It's a triangle, and now since you have this, you can project here, and then you have the height, and then you can find the circumradius. Okay, how am I doing time-wise? I think I have about 10 minutes, something like that. Is that correct?
Yes, sir.
Am I correct?
Yes, sir.
Okay, so maybe I'll skip some of this and show you a little bit of.
No need to skip, sir. You can take five more minutes if you want.
Okay.
Sir,
okay, so
you can take up to 4 p.m., sir.
Okay, well, I'll skip to stick to 50 minutes. That's right.
Okay.
Then we can see in the discussion. So this and the example that, so I just show you one thing which is funny, because I mean, especially here it would be interesting. You know that Bhaskara, the Bhaskaracharya has a verse that begins with Savador Yuti Dalam, which doesn't say that the formula is correct. But Saraswati Amma in a book on geometry points out that when oftentimes possibly in Jeshtadeva, when he says Savador Yuti Dalam Adi, he may not be referring to Bhaskara's verse, but to an emendation of the verse, which also starts with Savador Yuti Dalam, but which tells you that the formula is exact for triangles, for quadrilaterals with the distinguished diagonal, that is for which the diagonal is given by Brahmagupta's formula. Might use. So the point I was trying to make here, and there are lots of examples, I've only given you one, that what I call apodictic discourse, something that must be rigorous, conclusive, and motivated, that needs to be adapted to several types of audience at once, and you cannot spell out everything, but it must be possible to determine everything by analysis. And in mathematics, apodictic discourse is a normal form of teaching in ancient India. And the unwritten form encourages thinking on words and meanings, and rather than objects of the sentence, senses, which would be diagrams of figures that in sense of numerals. And the text should be read at several levels. This is a basic tension between Stula and Sukshma that anybody is familiar with Indian mathematics knows very well. And the conceptual framework, that is the required background, should be scrutinized because the modern conceptual frameworks are not enough, and sometimes the conceptual framework, especially for Baudaina, has no modern counterpart. Let me just stress rapidly that the southern sources are very important in the discovery of Indian mathematics, and the way southern sources were handled explains in a way, it's one of the reasons, it's not the only reason, why the analysis of proof structure in India was not studied sooner. So the point is that, first of all, there's the issue, of course, of conceptual background. It took some time to realize that Brahmagupta does not use the notion of angle. I've already mentioned that, and that ancient conceptual frameworks in general are not modern. And there's also the fourth point here, the emphasis on deductive arguments, but there's also the neglect of southern sources. You need to remember that in the late 18th century, so it's 17 something, the Vakya system was given an exposition in French by an interpreter who was an informer of the French government. And it's something like over 200 pages on the Vakya system. And there is a French person called Le Gentil who came to India to observe the transit of Venus. And he was interested in the Vakya system because it was efficient. It's because of efficiency that he was. It's not out of curiosity. But it's fair to say that nobody cared for all sorts of reasons. And then in 1817, Colebrook, who was impressed by the quality of Indian mathematics, gave a highly influential translation of Indian mathematical source text from northern Sanskrit sources. The French were based in Pondicherry, and so near Pondicherry. The Pondicherry used to be a part of French territory for some time, until 1962. But Colebrook was based in Calcutta. And there is a contradiction between star catalogs in Brahmagupta and in some Tamil sources. I briefly mentioned that at some point, including in the French work. So you assume that the southern sources were faulty. That is, you assume that since Brahmagupta was extremely consistent and seemed to have a very important place, he was the dominant figure, and therefore everything that doesn't tally with that, and that's not part of a consistent whole, should be faulty, which was logical from his point of view. This being said, up until the 1840s, that the latest I know was 1845, there were extensive texts on the Vakya system in Tamil with translation, partly based also on Telugu sources, that describe, the Vakya system of Varuchi. Okay. And this is in that context that the basic words of the Madhava school were mentioned. And nobody cared, but nobody believed that these things were not borrowed from outside, because the astronomers who talked to foreigners did not provide the derivation. Of course, there are many people all over the world that use formulae that they don't understand. That happens. So they believe that they had access to everything. And then everybody knows it's only in the early 21st century, the latest is the publication of Karna Pardhati that you heard about this morning, that the words were finally edited, translated 200 years afterwards. I mean, it's really, okay. And you need to understand that Colebrook knew Brahmagupta, but he didn't even know about he knew that Aryabhata existed, but only because Brahmagupta criticized him in the 11th chapter of Brahma Sudha Siddhanta. He did not have the text of Aryabhata. he believed that Arya Arthasata meant 800 Aryas, because he couldn't believe that it was, so much shorter than Brahmagupta has 1008 Aryas. So he assumed that 800 would be a reasonable figure. It's actually 108. It's not, that was pointed out later. He didn't have the Suva Sutras. So he assumed that there was nothing. But if there was no mathematics before Brahmagupta or Aryabhata, well, that means that mathematics was influenced by foreign sources. That's logical. And therefore, there's no point in trying to understand blah, blah, blah. And so you see in his dissertation on the mathematics of the Hindus, he said, a long and diligent research in various parts of India failed of recovering any part of Aryabhata's and others' works. But we know there were many copies. So you see, it's quite logical that Colebrooke was at a loss to understand, because he wasn't able to get copies, but the sources were in the south. They were not near Calcutta. And when Kern in 1875 actually published Aryabhata's text, he was starting from other sources from Kerala. That is precisely the point. And the lack of communication between the British, who were based primarily in the north, and the French Indulgent that were basically around Pondicherry. And there are some Germans who knew Tamil also, but not that many of them. That was a really big problem. And Colebrooke thought that all later authors merely developed Aryabhata, whose text he didn't have. Okay. So that gives you the gist of the current problem. There are other issues that I'm not going to discuss here. Let me just say a few words of conclusion. So I hope to have convinced you, at least, or to have suggested that the idea is plausible that the Indian mathematical texts do contain that contain original ideas are apodictic discourses, and not deductive discourses or lists of rules. That they are discourses that contain proof within their own discursive structure. They don't need a commentary or things. I mean, if you have a commentary, fine, but there are many things that you can get by looking at the text themselves. And they include elements of motivation that may be read at different levels, so that it's eminently adapted to different audiences at the same time. And the notion of apodictic discourse, I haven't had much time to explain that, of course, but I hope you consider this as at least plausible. It helps understand mathematical texts in other cultures. And this was missed because of an overestimation of dogmatic discourse over the apodictic, particularly in the British Empire. And there's a paper by Cajori which shows that the French and the Germans were beginning to understand that Euclid's elements and ancient Greek geometry are simply wrong, and you need to replace it by a completely different set of axioms, and it doesn't work at all. But at the same time, in the British Empire, and it seems to have been the only place in Europe, they kept using Euclid's elements as the standard of mathematical instruction. So that was a really problem. And of course, the neglect of southern sources. So that's why I'm very happy that steps are taken to make things to actually have the text. If we don't have the text, we cannot say anything. We need to have the text, and we don't need speculation about text. We need to have text and analysis. So to come back to the issue of oral communication, of course, it's the passage, favors the passage from sensory perception to word representation, and hence to abstract thinking. And the fact that a student can and should think by himself or herself, and not be simply imposed upon by the teacher, is preserves freedom of thought, which is certainly one of the reasons why new things were developed in India. And so this implies, of course, that when we look at new texts, we need to ask ourselves a certain number of questions. The one I would like to stress in conclusion is that priority is not a priority. The issue is not to say who did it first. The issue is first to understand what the texts say. And precisely it's because one looked at priority that people didn't look carefully enough at mathematics, mathematical texts from India, especially from the South, because you assume that they don't have proof. And since it's not in Sanskrit, it's probably not going to be interesting anyway. So you see, this is really, all kinds of prejudice are not helpful, because you need to know what the texts say, and then we can decide whether they're interesting. Then we can decide whether they're original or not. Priority is not a priority. I thank you for your attention. Yeah, I think it would be 52 minutes. So
Thank you, sir.
Thank you, sir. That was truly enlightening session. Now we are moving on to the discussion. If you have any questions, please raise your hands or mention your name in your comment section. Okay. So there is a question. So please feel free to ask.
yeah, I see the hand raised, but I don't hear the question.
Yeah, thank you. Is it audible?
Now, yes,
Yes, please.
it's a bit blurred, but that's okay.
Yeah. Yeah, thank you very much for this excellent interpretations, especially about this priority issue that India almost never had it. Like most people almost never say who said what.
Right.
Yeah. But I had a few questions going back here, about three of them mainly. One is about the reference to cyclic quadrilateral. You said it comes from Brahmagupta. References by Bhaskara and a little bit on a few of the such nice theorems were proved by Narayana Pandita.
Right. I mean, the sequence of events is this, as we understand it. So in the commentary by Prithu Kasami in the 9th century, he didn't understand what was going on, simply reproduced the proposition, and he gave a numerical example, and he didn't understand what was going on. Then Bhaskaracharya said that, well, he said two things. First, he said that the formula cannot be true for a general quadrilateral.
Right, right.
So obviously, he didn't see that the quadrilateral was inscribed in a circle. I don't understand why, but it's very clear from what he said that because he makes the explicit criticism. He makes a second criticism, which is that the formulae for the diagonals are not true, of course, for general quadrilaterals, but they are true for a certain class of quadrilaterals obtained by scaling from two right triangles in a particular way, which he indicates. And for this particular class of triangles with perpendicular diagonals, so what there's a simpler way to compute the diagonals. And why did he give us a complicated formula where there was a simpler formula? Of course, the simpler formula doesn't apply to the general case. That's the reason. Okay. So there
was a generalization, in some sense. There was a generalization in some sense.
I mean, no. I mean, what Bhaskaracharya said is more special.
Oh, I see.
Brahmagupta is more general, and you say, why do you give a complicated formula? Well, the answer is because Brahmagupta's formula is more general.
Oh.
And then Narayana Pandita started looking at quadrilateral in Niyata Karna, that is determined diagonal. That is, what happens if you have a quadrilateral in which the diagonal is given by Brahmagupta's formula?
Oh, so she further analyzed only with given context.
Yeah, yeah. And then the proof of the so he obtained a number of things, and he introduced the notion of interchange. That is, that you can, if you have 4 chords, you can put them in different orders, and that generates 3 diagonals, and it improves the number of things. And then this was taken up by the Kerala school, and this gave the word. And you have some words also. There is a proof in Arabic I think by a group around Al-Biruni, I think. It's extremely complicated. They call it. They understood it was cyclic. They said it's a theorem attributed to the Indians. They don't say Brahmagupta, but and it has some elements that are found also in the Kerala proof, but it's a lot less. I mean, the Kerala proof is a lot better, but it relies on the third diagonal, and like I said, Brahmagupta does not introduce the third diagonal because it would be very easy to state.
Where does that come from? The third diagonal, who introduced? Is it Kerala school or before?
First in Narayana Pandita.
Okay, Narayana.
If I'm not mistaken, I thought.
Yeah, Narayana Pandita had the third diagonal.
Because I mean the logic is very clear. I mean, and I don't know exactly why he started doing that, but he's the one that started taking. And the Narayana Pandita's Ganita Kaumudi is interesting because it's also in Arya meter, and there are things that seem to indicate a connection to Brahmagupta. He seems to have taken Brahmagupta seriously, but so these things need to be investigated. I think there is a paraphrase of Narayana Pandita, and but I don't remember the exact number of the propositions. But if anybody is interested, I can look up and try to dig up the exact.
Yeah, thank you. The next question is, does it really have application in astronomy? Because no other astronomers never touched this, and only Brahmagupta touched it, and it comes to Kerala school. Actually,
you know, if you look at the what is called the Ptolemy's theorem, which is a consequence of
Ptolemy had something to do with cyclic.
Right. That's what you get from Brahmagupta's formula by taking the product of diagonals. Well, that is used by Ptolemy to construct signs.
Right.
So these things are used
in the Kerala school or in Indian astronomy. Has it ever been used? Seriously?
Actually, it depends on when you read the way you read you see. I stopped at 32, but from 33 to 38, there are formulas that show you how to generate cyclic quadrilaterals with numbers. And these formulas can be interpreted. For instance, there's formula for something with 3 equal sides. These could be interpreted as trigonometric formulae.
Is it only could be, or have they done it? Kind of, did he write it? My question is like Jeshtadeva. In the beginning, he says, I am writing things for Tantra Sangraha. And then this is something which doesn't seem to have an application or directly used.
I'm sorry, could you say that again? I have difficulty hearing you. Could you repeat your sentence?
Yeah, Jeshtadeva, in the beginning, he says he is drawing all mathematics to do the astronomy, the Tantra Sangraha.
Oh,
and he spends a lot of time on cyclic quadrilateral, and it doesn't seem to have any direct impact on that part, is what I heard.
Yeah. No, I was not talking about Tantra Sangraha. No.
Yeah. So
I was thinking, no. Yeah. So I mean that's the problem with late sources. The things like Tantra Sangraha or Yutti Bhasha, you know that these are not the ones that invented the theorems. Because you know that they were tested, 1,000 years before that. So their motivation is certainly a lot more complicated than Brahmagupta. Since in this particular case, we can fairly, with some safety, say that the theorem originates with Brahmagupta, then we can say that the reason for that is probably comes from Brahmagupta. Oh, I didn't mention another element of motivation. It's Brahmagupta begins with the gross and the exact formula. Now, what is odd is that, and so in the text that I know, I don't pretend to know everything. The gross formula that he gives is something that you find in Egypt or in other places. I haven't found it in India before Brahmagupta. So it seems, well, if you take Brahmagupta's text as face value, it seems that what happens is that somebody came to him telling him, well, why do you make all this fuss? We can find, for all practical purposes, the area of a cyclic quadrilateral by this approximate formula. And then he probably said, well, this can't be wrong because it's not symmetric. So you see that it looks like this is the thing that got him thinking in the first place. And then, of course, probably he was also interested in trigonometry. The reason I say that is that there is a passage in Aryabhata where he says that the sines in general should be computed by investigated triangles and quadrilaterals in a circle. But it doesn't say how to say that. He doesn't explain how to do that explicitly, but he draws explicitly the connection between trigonometry, the list of sines, and triangles and quadrilaterals. So that's the reason why I focus.
For me, I thought that was interest of quadrilateral was just purely mathematical, kind of nothing else. I mean, it's a pure intellectual work.
Well, I mean, in any, for instance, when you take, is there something that is purely useless? It's not clear that there is. If you do something, you have a reason. It may not be a physical reason or something like that, but it's very very difficult to say that something is entirely useless. Let me give you one example. You take the Fermat's last theorem. Okay, you know that Fermat, what he actually published was, he said that Fermat's last theorem is supposed to hold for exponents 3 and 4. He didn't say anything else. And then there is this famous passage in his private copy of Diophantus that his son published later, in which he claims to have a general proof. Now, ask yourself, why did he mention the case of 3 and 4? And why was he interested in that? Well, I have one element which I don't understand why is almost never mentioned. There is a text in Arabic a few centuries earlier that is a list of open problems. And in this list of open problems, there are 2 of them that are the cases of 3 and 4 for Fermat's last theorem. Therefore, it's clearly the problem does not originate with Fermat. Now, in this Arabic source, why did he collect these things? So this means that these problems had been discussed before. Probably, for cubes, I can understand. You say, well, it's possible to add 2 squares and have another square. Is it possible to have 2 cubes and have a cube? But why 4 powers? I don't know. But in order to say, I mean, there's a difference between I don't know and I can say that this is useless.
Yeah. And just the last point I want to say is, like, on the cyclic quadrilateral, he goes on so much. Why? For the higher degree equation, after doing the linear and then the quadratic, then he says, since the cubics and for this thing has no interest in astronomy, I'm not going.
What has no interest in astronomy?
The cubics and the cubes and the cube roots. So Jashdeva says explicitly.
There is a reason.
So I'm not going to do it. So it seems that intellectually there was, like Chitrabhanu's work, there was work on the cubes and so on, but Jashdeva just washed his hands off and say that I'm not going to get into it.
No. There is a, one can understand. I mean, your question is an interesting point. There is, I mean, Brahmagupta does explain how to extract cube roots at the beginning of chapter 12. So he has this concern, but and he's probably using, and there's the part on the Chiti Vyavahara where you probably need things like that. So there is some material on cubes, but in the 18th chapter, when he introduces what is called Karni, the Karni for Brahmagupta are irrational square roots, he's careful to say that they can be constructed as perpendiculars of certain triangles, which he indicates. Therefore, I would surmise that, at least for Brahmagupta, he's not interested in cube roots, in irrational cube roots, because he doesn't have a construction for them. And the new element that you get, especially with Tartaglia, is that he's using a kind of, he's saying that there is a kind of approximate or arbitrarily good construction that he described with that was known a little bit before, that he considered to be legitimate. And this is the shift. I mean, this is the reason why what happened with Tartaglia was important, is the extension of the notion of numbers to think that you cannot construct explicitly. So that is, and it is interesting also, and I agree with you that in the case of Chitrabhanu and these people, they're always interested in Sanskrit at least, they're only interested in integers. But like we saw this morning in the Malayalam version, well, there's this iteration process which implicitly involves cube roots that don't fall exactly right. So, but that is the real issue. Did Kerala mathematics consider irrational cube roots as legitimate quantities? That's not clear.
Thank you.
Am I audible?
Yes, please.
Am I audible? Yeah, I'm Arun Aswagan.
Yes.
Thank you for your presentation. Here, I need to explain two things. I have two questions.
Yes.
It is about orality one. Another is referentiality. Okay. If I found that you used a word figure, geometry without figure.
Yes.
Perhaps figure means perhaps you intended that figure is a visual sign, perhaps, isn't it?
Well, I mean without diagrams.
Yeah, okay. Visual sign, no? Yeah, geometrical visuals. Visual signs, no?
Visuals?
Sign with vision signs, no? Signs.
Vision signs.
Visual signs, signs, visual signs.
Oh, visual
signs.
signs. Visual signs.
Yeah.
No, I meant without diagrams.
Yeah. Then here your main argument is based on Predictive Discourse, isn't it?
Yeah.
You explained it that cannot spell out everything, but it must determine everything by analysis.
Right.
Yeah. Here we know that the oral knowledge is important here because we cannot understand the oral text without an interpretation, isn't it? Analysis means interpretation, no?
No. There's a difference between, so there's a difference in analysis and interpretation.
Yeah.
When I mean analysis, I'm saying that the master tells something to the student, and he has a pretty good idea of the student's background. And this background, the text by itself may be subject to several interpretations. But if you combine the text with the context and the background knowledge, then this shrinks. And you don't have much room for interpretation. For instance, in all the cases that I've published, I have never seen anyone give me a possibility to interpret the text in a different way.
Okay.
In all these cases, I agree that there's room for interpretation only if you cut off the text. For instance, if the context is lost and you just have the text and you don't know anything about the culture or anything like that, then it's an example of a wrong interpretation was the way that Schall or other Europeans worked, because Schall took Colebrooke's translation, and he didn't know Sanskrit and didn't know much about India apparently, and then he tried rearranging the propositions in a different order. Well, this is what he meant.
Yeah.
But you see that he could do that because he didn't take into account the entire context. In particular, he threw away the order of the propositions in particular, and he didn't look at the text. So, and even for instance, to take the example that you mentioned in your talk, well, even in Yerm-Suvedi, I mean that's a rather extreme example, but that to show you what I mean. If you even Yerm-Suvedi contains some information. If you look at the order of the numbers of the signs, you see, if you take the way they are classified in such a way that even if you don't really know the full system, you can infer what the system has to be because it's ordered in a very particular way. You see that you have first the Mundri and so forth, and then you have something which is added to that and so forth. So, and if you only know, for instance, the symbols for 1, 2, 3, 4, 5 up to 11, there's a lot that you can get just by analyzing the text. It's not about interpreting that. If you assume that the author is not an idiot, there are things that have to be there. But of course, if you don't know if the text is really something coherent, if you don't know if the text is composite, for instance, then you cannot do these things. And then you have to resort to interpretation. That's another thing. You see, so there is a continuum between analysis and interpretation that has to be taken care of. That depends on how much you know and how much you know about the context and about the culture.
Okay, then if we few of the argument of Kerala school,
yes,
or the scholars of Kerala school,
yes,
registered the argument without proof and referentialities, isn't it? Yeah. So
well, for the Kerala schools, they did have proof.
Yeah, but before Yukti Bhasha, the proofs appeared in Yukti Bhasha, but the earlier text, if you consider the earlier text, proofs are not deliberately elaborated in certain way. So my question is that if we consider a text without proof, or if we read a text without referentiality,
Yes.
how we understand the meaning of the text?
Let me give you an example that I pointed out in my review of Karana Paddhati that appear in the Indian Journal of History of Science. There's a passage in Karana Paddhati where he gives series for the sign and stuff like that, or for pi over 4 equals, I mean, the well-known formulas that are found everywhere without proof. And then there are three propositions. Let's call them A, B, C, never mind the numbers. So A is highly non-trivial, is given without proof. Okay. B tells you how to reduce a certain type of fraction to the same denominator. It's extremely elementary from an Indian point of view, something that you know, in Aryabhata and Brahmagupta, that looks really stupid. And C is a different form of the result of A. It's a rearrangement that involves fourth negative powers of n, and therefore it's better for computation than formula A. So what I pointed out is that what he's saying is that the argument B, the elementary argument in B, is what you should use in order to transform A into C. So that is the proof. Okay. It's this part that indicates the proof. But the harder theorem A is not proved because it's taken from somewhere else. So there is no proof in this case. But we know from the context why there is no proof, because it belongs to a corpus in which the proof is elsewhere. So you see, there are two different situations. The passage from A to C is proved, and it's proved, it's an example of what I said, that if you take A, B, C as a sequence of statements, that unrelated statements, it's stupid. If you say that B is the argument that enables you to go from A to C, then it's a good proof. It's an interesting way economical way of stating it. But at the same time, the A itself is not proved because we know that the proof is quite hard. In the way he's stating it, there's no way the proof could be hidden in this small text. Therefore, that's what I said about the implied background. He has in the background a certain number of things. If we don't know what he has in his background, we cannot understand why he states certain things with proof and others without proof. Here, he seems to be giving a proof of something relatively simple and not giving a proof of the harder theorem, probably because his own contribution was the passage from A to C. And he knows that his audience will be able to look up Yukti Bashar or something else to find the proof of the harder result. You see? So the thing should be analyzed on a case-by-case basis. Sometimes no proof means no proof. Sometimes no proof means something else. But you need to scrutinize. For instance, is there something? Do you understand every other, every proposition or other proposition that you have to discard or think, well, that's obvious. If you think that look too obvious to be there, then there's something wrong. And it has to be done on a case-by-case basis. It's hard. I mean, I'm not saying it's easy, but it has to be done on a case-by-case basis. You see what I'm saying?
Yeah, thank you. But I need to ask one more thing.
Yes.
Then here we need an accumulated or informed knowledge to read that text.
Yes.
First of all.
Yes.
That means in the absence of an interpreter or an analyst, that analysis may not produce meaning. Isn't it?
Yes, like I said, you need to have an idea of the. I mean, there are two things. First, you need to understand what the context, the conceptual framework is. Otherwise, you're going to go astray. On the other hand, for people like Brahmagupta, I mean, we know that these people, and it's the same is true for Tamil. I mean, the Pullavar. This is not about common conversation. The language that they use is highly sophisticated, and they know how to use all the resources of language. And if you look at since I think you have read a little bit of Sangye Lekyon.
No, I don't know.
Oh, okay. So if you take the ancient Sangam literature, you see that there are people talking to each other in highly indirect terms. They, for instance, a woman might talk to a toji, to a friend about a man in such a way that people that overhear what they are saying will not be understood. So there are lots of methods to make things intelligible to a class of people, not to another class of people. And so we are talking about discourses that are very, very elaborate. They don't just come out and speak normally. That's not the way they do. For instance, if you look at the biography of Meenakshi Sundaram-Pillai, who is the teacher of Uwe Saminath, one who edited an enormous body of ancient Tamil text, his job was to receive money to compose Tadapurana and things like that, and he was hired to do that, and Saminath Iyer, so his students saw that Meenakshi Sundaram-Pillai didn't seem to be working on it at all, and he was beginning to be a little bit alarmed because he really needed the money. And then someday, while he was handling his accounts with someone else, and then at the same time, he dictated parts and bits and pieces of his work like that, no correction. And then at some other time, they were traveling on the Martavandi, and then he simply found out he has composed everything in his head, and then at the last minute he produces it. That's it. So that's a way of functioning that has absolutely no modern analog. And so people have written things in very, very, very controlled way. So if they use one word, it means that they mean this word. They didn't use another word because this is what they say, and they have a very, 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 very precise, discourse that they have. So that's why I'm saying we should think about in terms of discourses. And when we are talking about really, original scholars, when they say something, they mean it, and they usually have given you ways to understand them correctly and to correct any errors. But I'm not saying it's easy. I'm only saying that it needs to be done, and it's really very, very exciting when you do that. Yeah, am I? You see what I'm saying? I don't have any feedback. Is that okay?
Professor, you can stop
Yes.
sharing your screen so that we can
Hello.
see you.
Okay.
Hello, sir. Hello, sir. Am I audible?
Yes, you are.
Myself, Janaki, second year math student in V.T.B college. First of all, I would like to thank Professor Satyanath Krishnaswamy sir for presenting a wonderful session. My question is that what changes should be learning and teaching in India to enhance reasoning skills related to math?
There's some echo on the line. Could you rephrase the question? I didn't quite catch the question.
Hello, sir.
There was some echo on your line, so I
Okay,
didn't
sir.
quite catch your question.
What changes should be brought in the style of learning and teaching in India to enhance reasoning skills related to maths?
Oh, what are the implications for teaching in schools? Is that what you're saying?
Yes, sir. What changes should be brought?
What are the major changes that should be brought in order
What
to?
are the what?
What are the changes that you wish to see in the Indian context of education, especially in mathematics, to improve and enhance this teaching and learning skills in students?
I think that there are two things. I think it goes in the same direction like what Dr. Parvati said. First of all, things should be really motivated and should not be given from the top down. For instance, one example. If you see that the notion of angle is something that is a construction that has been abandoned by modern Indian mathematicians or French mathematicians for that matter, then it would be advisable not to use the concept of angle as a self-evident object. If you present things to children who are saying that they are natural while they are not natural, then of course they are not going to understand. That's normal. But on the other hand, if you start working the way Indians did, that is with quadrilaterals and circles and trying to find the length of a circle, an arc of a circle, that's something that's natural because this is the way things happen. And so for everything, similarly, if you from an Indian context, the isosceles trapezium is a fundamental figure. It's more fundamental than the triangle. Because if you start from a circle and then you have two lines like that, and then you have something which contains both a triangle with an obtuse angle and one with an acute angle, and but they have the same height. And so you see, if you start rethinking the curriculum from the point of view of the way things actually happened in India, it's actually both something that is reasonable from an Indian point of view, and so also something which is easier to understand. I mean, Brahmagupta's theory of the cyclic quadrilateral is very natural, and it's very easy to understand. Of course, for students, you have to make it longer to explain all the steps, but that's not very difficult. So that's something that should be done. And again, the notion of attribution should be made clear. But for instance, I want to stop calling Pythagoras' theorem. I mean, we have no statement, we have no text that says that there is someone kind of, we have no theorem that would have been spoken by someone called Pythagoras. Simply don't have that. The attribution dates back to something like 500 years after the possible date of Pythagoras. So if you tell children that they have to use a theorem that comes from some foreigner that maybe never existed, of course they are going to say, well, why do you want me to do that? So these are historically informed teaching is something that's very important. Could take longer to explain. Hasn't been done for about 100 years for other reasons. But now people want to know, and people have the right to know that in India there are things that have been done. There are things that have been done elsewhere. That's also very interesting, and all these things should be taught together. And the other thing is, I think, if we want to go in the direction of oral instruction should be combined with times where people are allowed to think by themselves. And that's something that, if you want to nurture freedom of thought, people should have the right to say, well, let me think about it. Maybe this is true. I need to think about it. And then come back to the teacher. Exactly the system that you see in the text. There's Sandegon, there are doubts. Well, you said that, but I don't understand this because it seems to me that, so forth. So there are all sorts of modes of teaching that used to be found in India that are close to the way people talk to their own families, talk to their own parents, that may be reinstated. And I think the first thing in teaching needs is truth, that you shouldn't tell people this is obvious when this is not obvious, this is important when this is not important. And the other thing is freedom, that you have the right not to understand. And one thing I often said to my own students is that if you don't understand, it's a sign of mental health. Because if you don't understand, it means that you're beginning to realize that this is not necessary, that maybe things could have been presented differently. Maybe this is not the way things evolved. You're beginning to take charge. So this is very good. And this should be nurtured. And I think it is in the spirit of the interaction between old and young people in Indian society, at least in what I have seen and what used to be the case in the time of my parents and my grandparents. And maybe this is something that's feasible in the Indian context. I hope this helps.
Thank you.
Is there any other questions? Please feel free to ask.
Arjun?
Yeah. Okay. Now we will move on to the vote of thanks. I would like to invite Ashwin N. Prakash, student BSc Mathematics, to come forward and deliver the vote of thanks.
Hello. Good evening to one and all. I'm honored to have the opportunity to thank each and everyone present here. We all know Indian mathematical text from the earliest times apparently contain little or no indication of context or proof. Those that present original results contain no figures. Even when describing complex geometrical situations and often do not give numerical examples, these remarkable features call for an explanation. Indeed, to express geometrical theorems without writing or drawing, it is necessary to replace concrete objects by abstract ones and to carry out reasoning directly on mental objects. Through this session, we were able to learn more about geometry without figures. Hence, I extend my gratitude to Professor Satyanath sir for sharing your valuable findings on geometry without figures. You are an exemplary person, sir. We have a lot to learn from your scholarly talk. Thank you, sir, for finding out time from your busy schedule and enlightening us with your insights. Thank you so much. Also, thanks to all the students present here for the lively participation. I, on behalf of Sri Krishnapuram V.T.B College, would like to extend hearty vote of thanks to all the delegates of the seminar for their presence and contribution to make this session successful. Thank you.
Thank you, Ashwin. With this, we have come to an end of session 9, and now we are moving on to the validatory session. Sri Krishnapuram V.T. Bhattadripad College is a government-aided arts and science college in Palakkad district of Kerala, affiliated to University of Calicut. The college is named after V.T. Bhattadripad, who is acknowledged as one of the pioneers of social revolution in Kerala. The college is under the management of Sri Shankara Trust, started functioning in December 1982. The college offers undergraduate, postgraduate courses in different disciplines. In the year 2019, the college got approval from University Grants Commission to execute an interdisciplinary research project under the scheme of UGC Stride Component 1. Stride Component 1, applied by our institution, has approved by UGC on the topic, Vedic education system in Kerala. A comprehensive scientific and interdisciplinary analysis, Sri Krishnapuram V.T. College is one of the 5 institutions of Kerala who got approval under UGC Stride Component 1. This project was to bring out the salient features of Vedic education system of Kerala against the backgrounds of Indian Vedic tradition to explore its amazing vitality, intellectual impact, persistence, and oral strength. The study was an in-depth analysis of the effects of the system. Indian astronomy and mathematics are the 2 gems of the ancient Indian scientific tradition. India has a rich past in these areas since the ancient times. Vedangajyotisa studies the mathematical and astronomical features with a scientific outlook. In the 12th century AD, by scientific research conducted in these 2 branches deteriorated in most parts of India, steady progress of the same was visible in Kerala. It continued to the same until the 18th century. During this time, Kerala contributed greatly to astronomy and the theories of great scholars like Vadasheri Parameshwaran and Brahmagupta. These areas has been saintly and provides scope for our initiatives. To begin the validatory session, for the welcome speech, I would like to invite Shruti P.A., Stride member, Department of Sanskrit, Sri Krishnapuram V.T. Bhattadripad College, Manavatta, Palakkad.
Yeah, thank you, Arjun. Good afternoon, everyone. We are closing to the end of this conference. It's always nice to end things on a bright note. Firstly, I would like to thank everyone, each and everyone who made this conference successful. In this session, we have a chief guest who is always involved in academic activities, Dr. C.M. Nilavanthan sir, UGC Stride Project MMC member, retired professor in Department of Sanskrit Sahitya and Vedic Studies, Sri Shankaracharya University of Sanskrit, Kaladi. He has been working in the area of Vedic studies actively. Dr. C.M. Nilavanthan was awarded Sahodharan Ayyappan Sahitya Parishad in 2006 and Kerala Sahitya Academy Endowment Award for the work Shruti Saurabham. He has numerous publications, appreciations, and awards in his account. A warm welcome, sir, to this conference. Next, I welcome our beloved principal, Dr. E. Jayan, sir, who has been supporting us entire the course of UGC Stride project. Welcome, sir. And I welcome Parvati ma'am, convener of this conference and coordinator of UGC Stride Project Component 1. And of course, all the resource persons and other scholars, welcome. I welcome all the participants who actively participated in the conference. Once again, welcome all. Thank you. Over to you, Arjun.
Thank you, Shruti ma'am. For the presidential address, I would like to invite Dr. E. Jayan, Principal, Sri Krishnapuram V.T. Bhattatiripad College, Mannabetta, Palakkad. Welcome you, sir.
I'm audible. I'm audible.
Yes, sir.
Can you hear me?
Yes, sir.
Good evening
Please.
to all. Good evening to all. Most respected Dr. C.M. Neelakandan sir, the coordinator, Stride program, Dr. K.P. Parvati, Shruti, Assistant Professor, Department of Sanskrit, and all participants. The 3 days of experience of the Indian Astronomy and Mathematics came to an end to this evening. I really appreciate the cordial spirit of the entire team of Stride V.T.B College. Thank you. Thank you so much. Thank you.
Thank you, sir. Yes, sir. Please. For the valedictory speech, I would like to invite Dr. C.M. Neelakandan, Professor of Sanskrit, Sri Shankaracharya Sanskrit University, Kaladi, and MMC member of UGC Stride Component 1 for the valedictory speech. Welcome, sir.
Am I audible? Sadashiva Samarambham Shankaracharya Madhyamam Asmadacharya Paryandam Vande Guru Paramparam. Respected chair of the validatory session, my close friend Professor Jayan, the chief coordinator of the international seminar, Dr. Parvati, and those who are vigorously coordinating the international seminar with Parvati, Dr. Reddy, Dr. Sudhi, and all others, Arjun and all others. I was partly attending the 3-day international seminar, not fully, because I was engaged with so many other seminars and lectures on these days. But many important lectures I have listened, I have attended, and I have fully convinced that the seminar was conducted very seriously, and the outcome of the seminar is really fruitful. I congratulate once more the organizers of the seminar for conducting such an excellent international seminar. Many stalwarts in the field presented their papers, and fruitful discussions took place after each paper. As part of the Stride component activities, we have to do many more activities. We have to coordinate so many other conferences and courses in the future. Now, regarding this particular topic, we have been listening all the papers on the 3 days. 1 or 2 observations only I to present here validatory remarks. First is that, as we all know, Kerala is a fertile place for the knowledge system, astronomy and mathematics. When compared to other places of India, Kerala is a fertile place. Medieval Kerala astronomy and mathematics has been accepted by the scholars all over the field as unique. Padasheri Parameswaran, Sangama Grama Madhavan, and many scholars are from Kerala who have contributed to the unique discipline of study. But one thing we have to understand, that though many works have been discovered from manuscripts and transcripts, there are so many other works still remaining undiscovered and unpublished in the field. In Kerala, in different parts of Kerala, in different depositories, manuscript depositories of Kerala. Some are known but not yet come to the light. Some are unknown, undetected. They are still laying in the manuscript depositories. For example, one work related to the Shulba Sutra, usually Baudhayana system of construction of the altars for yagas, based on the Baudhayana Shulba Sutra. In Kerala also, this Baudhayana Shulba Sutra is followed for the yagas, for preparing the altars, yaga vedis, in different forms, in the form of Kanga Chiti, Shena Chiti, flying Kanga, Shena, etc. And many important principles regarding to geometry and arithmetic are there in the Shulba Sutra works. Some earlier Shulba Sutras related to Vedangas are published, but there is a work included in the class of Shulba Sutra literature in Kerala. It is named Yogiyarude Kariga. Kariga means it is written in the Kariga form, and Yogiyar is the author of the designation of the author of the particular Kariga. That Yogiyarude Kariga is related to the building of altars of different types for yagas according to the Kerala version, Kerala system. This Yogiyar is taken to be a member of the Taikat family. We have 2-3 important Srauda families in medieval Kerala. That is Chermuk family, Taikat family, and Kaimuk family near Thrissur. So this particular work is supposed to be written by one scholar of the Taikat family, whose name is not recorded in the manuscript. He might have assumed the order of sannyasa, yogi, and the work was written after he assumed the order of sannyasa. So the work is named only Yogiyarude Kariga. That particular work is even now preserved in the collection of the Taikat family near Adapal, in our near place. This particular has work, it is identified, but it is not yet even subjected to deep study or publication, edition and publication. There is one work related to the Srauda sacrifices of Kerala, one PhD thesis submitted to the Calicut University, Kozhikode University many years before. and it has been published in the Calicut University publication series from the Department of Sanskrit, Srauta Sacrifices of Kerala, by Dr. Govindan Nambudiri, a renowned scholar from the northern part of Kerala, even now very active in teaching and dissemination of Sanskrit knowledge. His PhD thesis has been published. This particular Yogi Arude Karika is referred to in that work, Srauta Sacrifices of Kerala. And I have identified the manuscript there, but I have not got any opportunity to work on that seriously because I am not very profound in the field of astronomy and mathematics. What I am trying to state is that there are so many knowledge systems, knowledge in the even now lying undetected, unknown in the manuscript depositories of Kerala, which the young scholars can take serious efforts for studying and doing research on them. These conferences like these should be able to give enthusiasm to the young scholars to take up serious work on such topics. Now, today in the morning, Dr. S.V.T.B. Sharma was participating in a panel discussion, and for some time, I was attending that. Now, Dr. S.V.T.B. Sharma, his present day paper main topic was the contribution of the great scholar K.V. Sharma to astronomy and mathematics. Now we had the stalwarts like K.V. Sharma, Dr. Sri Krishna Sharma, Dr. Kunjuni Raja, etc., who were pioneers in the field of Sanskrit studies and research. And K.V. Sharma was especially concentrating on technical literature like Ayurveda, Ganita, Jyotisha, Vastuvidya, plant science, etc., etc. And myself and Dr. S.I.S. Sharma jointly has published a work called Dravya Guna Shatashloki. It is a work on Ayurveda written by a scholar from Maharashtra, Bhatta Trimalla or Trimalla Bhatta. And it has been published, edited jointly by both of us and published by Indira Gandhi National Center for the Arts, New Delhi. And in that work, Dr. S.A. Sharma has given a list of manuscripts in Tamil Nadu and Kerala, a very comprehensive list of manuscripts from Tamil Nadu and Kerala, in which unpublished, unedited manuscripts related to all these branches of technical literature like astronomy, mathematics, Ayurveda, Jyotisha, plant science, Vastu, etc. are given. There, he has stated that only the 10 or 20% of manuscripts already discovered in these fields have been identified, edited, published, and serious studies and researches on them have come out. Those among the manuscripts already discovered, major number of manuscripts are not yet unattended. They are unattended. They are not studied. So young, energetic scholars can take up very important projects to do research on them, editing them, publishing them, doing research on them, and creating new knowledge based on all these branches of knowledge. So this is very important aspect that we have to undertake. Such international conferences and seminars should enable to create enthusiasm and energy among us to undertake very serious new projects in these fields. Another important aspect we have to mention is that now Satyanath, I was attending fully the Satyanand, I was attending fully the talk, the paper presented by Satyanand, and he was presenting some very important aspects of our intellectual tradition, generally related to our all branches of knowledge generally, and mathematics specifically, and very valid discussion, valuable discussion also took place after the presentation. He was presenting the idea of 6 senses. But in our tradition, we have the concept of the 7th sense also. 5 senses, then mind, the 6th sense, and we have the concept of the 7th sense that is related to our Atma, Manaha Atma. And that 7th sense is intuitive faculty, intuition. We may call it bhavana when related to poetry or literary creative aspect, and intuition when we use the term related to other branches of knowledge. So not only study, but after studying all these things, another faculty also works in these fields, which helps to explore new ideas, new knowledges. Actually, no doubt this will become fruitful after the serious study of the Shastras preliminarily. But after that, this intuitive aspect, intuitive knowledge, 7th sense, we can say 7th sense, that also works. And many of the novel, creative, innovative ideas in all these fields have come out with the help of the intuitive faculty also. And in Nyaya, we call this Yogaja Lakshana Pratyasati. We have the Samanya Lakshana Pratyasati, Jnana Lakshana Pratyasati, then the third and the final one, Yogaja Lakshana Pratyasati. So mere acquiring of knowledge is not the final thing. After serious study, after hard work, after serious study of the intensive study of the Shastras, then we have to acquire the aspect of the intuitive faculty also. So all this helps us to explore new areas of study in the field. So we have to do so many things in the field that is very much important. And I think it is very late now. Already we have 5. The time has passed 5. So I am not prolonging with my words. We have many things to do in the future in all fields of knowledge, in Indic knowledges like Vedas, then Brahmanas, Aranyakas, Upanishads, and Vedangas, and all knowledge systems related to Vedas. And I think these kinds of seminars and conferences, serious seminars and conferences, will motivate us, stimulate us to take serious projects, serious studies in all these fields, and to create new awareness of our knowledge tradition, which will be suited to remodel our thinking, our knowledge in the present and in the past. With these words, congratulating the coordinators of the organizers of the seminar once more, I conclude my validatory remarks. I thank the organizers for giving me an opportunity for this. Thank you all.
That was truly inspiring, stimulating, and enlightening validatory speech. Thank you, sir. Thank you so much. Now we are moving on to the feedback section. We would like to hear from the participants about the 3-day international conference. Professor Satyanath, sir, would you like to please comment on the feedbacks about this 3-day seminar? You were participating all the days and all sessions. We would like to hear from you, sir.
Yes, so first of all, I was very happy that this conference was organized, and I think it was very, very happy to see what was happening in all the sessions. What I think is very important, there's something, it's difficult to explain in words. When you go to history conferences, there is a general spirit that you find, and it's very difficult to have the right spirit. The right spirit here, and this is what I have found, is people simply trying to go forward one step at a time. That is, there are texts, they try to understand text, and one step at a time they find new results. And I've seen many texts in. You see, I may, if I may recall something that for many years I was wanting to. I heard about the Kerala mathematics. I tried to find the Yukti Bhasha by Agenda Soraya and so forth. In the 80s, I asked in India, in Tamil Nadu, where I could find that. I wasn't able to get hold of these texts. And so only in the 2000s, after 2000, that I gradually got some of them, and then I see that things like Kriya Kamakari or the works of Chitrabhanu on algebraic identities, all these things are beginning to be published, and many others. I'm sorry, I'm not quoting all the works. It's really extremely pleasant, because when you want to know and you simply don't have the text, it's extremely frustrating. And this is beginning to change now. The texts that have been talked about for 200 years, people said that no, there is nothing to be found, and let us not look at the text. This is changing, and this is changing in a serene way, not as a I mean, there are people that have a competence. There are some of you competence in Sanskrit, there are competence in mathematics or in Malayalam or Tamil or any combination of those. And I see a young generation that is taking hold of the real problems, taking hold of their knowledge. They are taking the future in their own hands, and they are beginning to produce words that's beginning to be really interesting to me as a researcher. So I want to thank all the organizers for making this possible, because this is something very difficult to come about. There are lots of things that have to be taken care of, and I heartily thank and congratulate all the people all the participants that presented the papers for all their contributions, and I really urge them to continue in this direction, and I'm sure that many new results will come out in the future from this group of people. Thank you very much for allowing me to be a part of it.
Thank you so much for your kind words, Professor. I hope Professor Dr. Venkateshwara Pai sir is also with us in this session. We would like to hear from you, sir. Sir, we are waiting for your feedback, sir. Okay. Any participants? You can give your feedbacks about this 3-day international conference. Your feedbacks are very important to us.
Hello, I'm
Yes.
audible.
Yes, Fatima, you're audible.
I'm Fatima Dilna from S.V.T.B College, Sri Krishnapuram. I would like to say about this 3-day sessions. For me, I think for all, it's a great webinar, and also it's a clear and excellent presentations. And our conference was started by Rajan Kurikal sir with his valuable, wonderful keynote address. And I would like to say about our first session by Rama Kalyani ma'am. First of all, she's a wonderful speaker and a person too. And I feel interested when she explained about her 21 problems that even not in the modern textbook. For me, it was a first a new knowledge, and also she explained about Varga Karma problem and Varga Prakriti equations like that, and also Bhuja Koti Karna Nyaya. It's also known as Pythagoras theorem, and for me it was a new knowledge, and everything was a new information for me in all the sessions. And overall it was a fabulous session and it was fabulous webinar. I have really appreciate the wealth of knowledge and insight you all have shared, and thank you for such a great wonderful webinar.
Thank you, Fatima. Anyone else would like to comment or to give feedback about the 3-day international conference? Please feel free to say.
Hello, good evening. Namashivaya.
Good evening, sir.
Yeah, this is Dr. Srihari. Yeah, so the feedback actually is already given by our friend Fatima. And really, it's, I mean, many sessions were eye-opening sessions. Basically, I am from the background of Sanskrit, and always this mathematics and the ancient sciences always fascinated me for a longer number of years. And when while doing this PhD in Chandrasekhar, I come across with this binary, and a lot of things are there. It's really interesting. So as far as all these topics which were covered in these three days, really I feel that now it's the time come that this technical books should be taught in some certificate course or something like that. So my humble request or maybe suggestion that if in future if you organize some kind of group in which great scholars can teach us all these, that will be a great opportunity to learn actually. Otherwise, without a guru, learning by your own, sometimes lots of difficulties are there. Many problems remains problems. So better if something happens in future, please let us know. We will definitely join. So one by one, if we cover these texts, then in future maybe in 5 to 6 years, or maybe in the next 10 years, we'll get a good number of scholars in those particular area. So thank you so much for organizing this kind of international conference, and people who got an opportunity to present their thoughts within 15 minutes. That was also remarkable. So thanks a lot. In remaining sections, I mean, they were so good, eye-opening. Thank you so much. Thank you for organizing. If you do something in this field again, please let us know. Thank you.
Thank you, sir. That was Dr. Srihari V. Gokankar, Assistant Professor, Amrita Vishwavidyapitham, Chennai. Thank you, sir, for your valuable feedbacks.
Thank you.
Anyone else ready to give your feedback?
Am I audible,
Please
sir?
feel free to join. Yes, Agila, you're audible.
Good evening, all. Myself, Agila, from Sri Krishnapuram V.T. Bhattadripad College, pursuing MCom. We are very happy and grateful to have spent 3 days with the eminent speakers. And now I take it as a pleasure to say the feedback of the session 4 and 5. It's my privilege to thank our honorable speaker, Dr. E. Sridharan sir, for spending his valuable time for us. In the topic, observation and calculations of planets' position, contemporary steps in Kerala. He spoke about great work of Hindu astronomers in Kerala by using the Aryabhatian system of astronomical computation. He then gave us a quick look on eminent personalities and these traditional astronomers helped in the calculation and observations of planets' position. Then he addressed about the modern and later scholars who worked and updated on it. In short, he helped us try to analyze the steps and methods in the books written by these personalities with giving some examples. Thank you, sir. It was a useful session. The 1 hour you took was really worth it. The next session by Honorable Speaker Dr. S.A.S. Sharma, sir, spent his valuable time for us in the topic contribution of Professor K.V. Sharma to Kerala Astronomy and Mathematics. He gave us a clear picture about K.V. Sharma. Then he invited the panel discussion team who made great effort on research. The 3 papers were presented. The first paper took by Dr. Vrinda PM. She compared to the methods that have changed in the modern times and also mentioned some eminent personalities and scholars who helped in the changes in mathematics field. It was although a well and astonishing presentation. The next paper presented by Dr. Suraj R.S. It was such an honor to know about Professor K.V. Sharma and a proud moment for speaking to talk about K.V. Sharma in this session. Thank you for making us aware on the contribution and achievements by him. It is a wonderful presentation which made all us realize his contribution and value to the subject. Gidu S. Nath made her attempt to make us analyze and understand the methodology and structure used by K.V. Sharma to disclose the work of Parameshwara. It was a nice paper and helped to know the medieval guru in mathematics. It was a really nice presentation and a wonderful experience for us. It was a great effort made by team to reach this whole topic to the participant at a limited span of time. We really feel grateful to be the part of it. Thank you.
Thank you, Akila, for your feedback. Is there anyone else who wish to say feedbacks about the seminar?
Hello, sir. Am I audible, sir?
Yes, please. Krishnendu.
Good evening, everyone. Myself, Krishnendu, final year BSc Maths student of Sri Krishnapuram V.T.B College. I would say that the STRIDE International webinar conducted in our college is a great program, really well organized with plenty of detail in each session. I would definitely recommend. It was very clear and understandable. Now on the topic, the content and the context of Kanakatikaram treatises, based on the joint work of Professor Roy Wagner, Sir Arun Ashokan and Brinda PM ma'am. Sir Arun Ashokan discussed about the content, linguistic and stylistic form, context of views, relation to actual practice, the cultural values that the treatises reflect, and political economic reality that they reflect. Now on the paper, Dr. Sujay Kumar CK on his paper, Astronomical Speculation reflected in Dashatyai of Talakulathar Govinda Bhattacharya, discussed about the tenets applied in the Dashatyai commentary by Bhattacharya. He mainly explained about the independent explanation with valuable doctrine to each of the verses of Brahjada in various viewpoints said by the great scholar Govinda Bhattacharya. Now about the sections, it was one of the most enjoyable and informative webinar I have ever attended. Speakers were very articulate and knowledgeable while remaining interesting throughout, which maintained the audience attention for organizing, and very special thanks to the great speakers. Thank you.
Thank you, Krishnendu, for your feedback. And now we are moving on to the vote of thanks. For vote of thanks, may I invite...
Am I I want to speak.
Yes, Shahana.
Hello?
Yes,
Am
Shahana,
I audible?
you are audible.
May I? Okay. My heartfelt greeting to all the distinguished guests, teachers, and my dear friends who have arrived here today. My name is Shahana, and I'm a third year BA Sanskrit Sahitya student of V.T. Bhattacharya College, Sri Krishnapuram. Today's session on the third day of the international webinar, which was held for 3 days in a row, was to praise blindly the knowledge of Venkateshwara Paisar and the topic Karana Pathadi, a unique astronomical treatise, and Professor Satyanath Kitchnaswamy sir's explanation of geometry without figures, mathematics, as a Predictive Discourse in an Indian text. They were simply a session that any beginner would feel very curious to hear and understand. The Karana Pathadi of Pudumana Somiyaji is a special text in that it does not come under the categories. They show here that this nation is a natural outgrowth of the emphasis on non-written communication in India, combined with the need for freedom of thought, indeed, to express geometric theorems without writing, were informative and blazing ideas. Discussion doubts were very, very useful, and sessions were made to make all doubts known in a very simple way. Thank you, sir. Thank you, V.T. Bhattacharya College, for this fabulous webinar. Thank you all. Thank you so much.
Thank you, Shahana. For vote of thanks, may I invite our beloved teacher, Dr. Parvati KP, STRIDE Coordinator, Head of the Department of Sanskrit, Sri Krishnapuram V.T. Bhattacharya College, Mannabetta, Palakkad. Welcome, ma'am.
Hello. Am I
Yes,
audible?
ma'am. Yes, ma'am, you are audible.
Okay, thank you. Now, thank you very much for giving me such a golden opportunity. First, I express my pranams to respected dignitaries on this gathering of our conference. It is my duty and I privileged that I have been asked to offer a vote of thanks on this innovative, peculiar occasion, which is a rare combination of interdisciplinary scholars. I am happy to say that this conference is a significant, unusual, and distinct academic culture has been availed by our institution through the knowledge bridge tuned by our resource persons. In this occasion, I must recollect some experiences that made this conference fruitful. When we STRIDE team decided to organize such an interdisciplinary conference based on Indian astronomy and mathematics, we approached our stride mentor, Dr. C.M. Neelakanthan sir, for guidance. He took it very seriously and discussed with senior scholars like Professor Rajan Gurukul sir and so on. Then he gave me a list of resource persons of international grade. I wondered and anxiety. Then I had to do something, but through the guidance of Neelakanthan sir, we go ahead. And all the scholars we approached or replied very positively. Not mere positively, with strong, healthy support, which come to this fruitful event. We, Sri Krishnapuram V.T. Bhattatiripad College, always indebted to sir. And I express our sincere gratitude to Dr. C.M. Neelakanthan sir, who is our chief guest in this valedictory session. Thank you, sir. Thank you very much. And Dr. Rajan Gurukul sir also promoted us each and every step of our conference. And I express on behalf of Stride team and Sri Krishnapuram V.T. Bhattatiripad College our sincere gratitude to sir. Now, our beloved principal, Dr. E. Jain sir, he is the most encouraging person for us with his charming words and smiling face. He will not speak a lot, but only few words. But it is the booster to work hard for all. So, as a part of official duty assigned to me, I express our sincere gratitude to Jain sir on behalf of Stride team and on behalf of Sri Krishnapuram V.T. Bhattatiripad College. Thank you, sir. To the next, I have to thank all our resource persons who gave a well-built support and guidance to execute such a great event. Each and every person from that side pulled us to the world of ancient Indian astronomy and mathematics. Professor S.A. Sharma sir, Dr. Venkatesh Pai sir, Professor Satyanad Kishanaswamy sir, all stalwarts of the field or from multidisciplinary fields supported us. Actually, we availed a distinguished scholars like Satyanad sir only because of the healthy communication from Pai sir. That is, I realize Vidya dadati vinayam athava vinayarthameva vidya. These words are satisfied by Satyanad sir and Pai sir. Thank you, sir. Professor Satyanad sir was always present in our conference and engaged sincerely in the discussion platform. Thank you, sir. And A.J. Parameshwaran sir, Rama Kalyani ma'am, Professor Roy Wagner, Arun Ashokan, and young scholars like Suraj, Brinda, all are participated in this program very, very sincerely and honestly. Actually, Suraj guided me to approach Roy Wagner sir. So I express our heartful gratitude towards them with a humble pranams on behalf of Stride Component 1 and on behalf of Sri Krishnapuram V.T. Bhattatiripad College. Thank you all. Shri Guru Bhyo Namah. Now, I express our sincere gratitude to the Mentoring and Monitoring Committee team and subject experts team of Stride Component 1 who helped us in this, not only in this event, all over the programs and academic programs and field programs in Stride Component 1 project, especially the subject expert of our Stride team in the area of ancient Indian astronomy and mathematics, Dr. Sujay from Sri Shankaracharya University of Sanskrit, He's an eminent personality. Not only an eminent personality, he's a sincere man, honest man in the academic career. So thank you, sir. And Dr. Narayanan from Sri Keralavarma College, he's also our subject expert. He's also supported us in all of the programs. Thank you, sir. Thank you very much. To the next, I express our sincere thanks to the delegates and paper presenters who flourished our conference with their valuable registered participation. Thank you, everyone. Next, I express our sincere gratitude to the teaching and non-teaching staff of our institution who supported us with their presence and participation. IQAC coordinator, Dr. Sarita ma'am, she's our she's our guide. She will guide in our all the steps of research programs. And thank you to Sarita ma'am, and especially a special thanks to Kamal sir, Arjun, Arvind sir, who made the sessions live with their marvelous introduction. Thank you on behalf of STRIDE team and Sri Krishnapuram V.T. Bhattatiripadu College. Now, I express our heartfelt appreciation to our students who participated in the conference with full of mind. Not only our students from other institutions are also participated, and our collaborating institution students are also participated. I'm sure that they gained a vast area of knowledge which opened to the wisdom of Indian astronomy and mathematics. Thank you, my dear students. Now, I express our sincere gratitude to our own team. Maybe official, but this is not an official words from my heart. I want to express the teamwork done by us in these days, especially Assistant Coordinator Srimati Rati from Department of Commerce, who is not present here, but she is the master brain of STRIDE project. And thank you, my dear team members, my dear friends. Now, I express my heartfelt love to our technical assistants, Kumari Varada and Master Sangeet. They were my two hands to conduct this grand event. We bless them that the unique experience achieved by them from these days will promote their academic future and career in upcoming days. And this will help them in their social, cultural, and moral parts of life also. And as an obligation to this great event, I pray that this gathering must be a ground or a cause to work in the unique field of ancient Indian astronomy and mathematics. So, once again, I am thanking all who are present here and not present here. They motivated us in each and every step. On behalf of STRIDE Component 1 project, Sri Krishnapuram V.T. Bhattatiripadu College, I am thanking all of you. Thank you very much.
Thank you, ma'am. For the information of the participants, there is a feedback form available in the chat box. Please feel free to fill the form and send to us.
Arjun, now we are going to the Shanti Mantra. Okay.
Swaminathan.
Swaminathan is there?
Namaste, namaste.
Yes.
Sahana bhavatu, sahano bhunakto, saha viryangarabhavahai, tejasvina madhetavastoma vidhishavahai. Om shanti shanti shanti. Asato ma satgamaya, tamaso ma jyotirgamaya, mrityorma amritangamaya. Om shanti shanti shanti. Harihi Om.
Thank you. Thank you, one and all, who participated in this occasion, and we will meet again in such a great gathering. I hope so. I believe so. Thank you, everyone.